I'll now
Yes.
hand over to Richard.
Right, thank you very much. Yes, well, thanks for the invitation to speak. I think this is a really important day, so I'm really pleased to be part of it. So just a bit more background on what I do. I'm a climate scientist. I've been working in climate science for nearly 30 years at the Met Office, but also I'm a professor at the University of Exeter these days as well. I have a joint position across both organisations. I'm a lead author with the Intergovernmental Panel on Climate Change. We're currently writing our sixth assessment report. Unfortunately, part of it was leaked last few days ago, as you may have heard. But we're still writing it. I was also the technical lead on the UK's National Climate Change Risk Assessment, which was published the week before last. So I'll give you a few highlights from that, and also a general overview of climate change science to help with your background understanding of the issue. I'll just get my slides up. So, I mean, I could literally talk all day about science of climate change, but I only have 15 minutes. So there'll be many things I don't mention, and that doesn't mean they're not important. It just means I haven't got time. But basically, I'll be talking about where we are currently headed with current emissions and so on, our current trajectory, and also explain why we have a real urgent need for action on reducing emissions and limiting climate change, and why this is being described as a climate emergency. So there's a lot of evidence, there's vast amounts of evidence now that the climate is changing. We're certain the climate is changing, there's no doubt about that. In the bottom left, we have a graph of global average temperatures year by year from 1850 up until last year. This is a Met Office data set, but there's other independent data sets which show the same thing. We've warmed the world by over 1 degree Celsius now since before the 20th century. And I say we've warmed the world because, again, we know it's our fault. We have built up more greenhouse gases in the atmosphere, particularly carbon dioxide, but also methane and nitrous oxide and others as well. But carbon dioxide is of a particular concern because it lasts a long time in the atmosphere. It doesn't break down chemically. So once you put it up there, it stays up there for decades or centuries. And that's one of the reasons why we need to stop emissions rapidly, because we keep adding to the problem. Even if we reduce emissions slowly, we're still putting more stuff into the atmosphere. So it's a matter of stopping putting any more carbon dioxide into the atmosphere as soon as we possibly can. So on the bottom right is the graph of carbon dioxide in the atmosphere. And we've increased the levels of CO2 in the atmosphere by 50% compared to the pre-industrial era. So that's how much we've changed the atmosphere already. And to put that into context of the longer term, in the top right there, we are now way outside what the Earth has seen for at least 800,000 years in this particular record, which is from ice cores, and outside what was experienced by our species when we evolved. So we've definitely changed the world's climate, and it's getting hotter. And this is already having impacts. One of the things I haven't got in this slide actually is that sea levels are rising. They've risen by several tens of centimetres already around the world. But in terms of extreme events, we are seeing many types of severe weather events becoming more frequent. Sorry, has the slide disappeared for you? I have trouble here. Right, okay. So we can see many types of severe weather event becoming more severe or more frequent, and the chances of certain weather events are becoming more likely. So the flooding we had in southern England in winter 2013-2014, that was made more severe and more likely because of climate change. The heat wave we had in 2018, again, that was made 30 times more likely because of climate change. And that led to over 800 deaths, more than half of which were attributed to climate change. Last year, we saw a major heat wave in Siberia, which again is building up this year actually, but that heat wave in Siberia last year was assessed to be 600 times more likely because of climate change. And that had huge impacts, including wildfires, loss of permafrost, which is a potential feedback on climate change by releasing more carbon, and invasion of pests affecting the ecosystem. So this shows that graph again, excuse me, of the observed global temperature change. As I say, we've warmed the world by over a degree already. Where are we actually headed? Well, it partly depends on how sensitive the climate is to our own building up of greenhouse gases, but it also very much depends on how much greenhouse gases we put into the atmosphere in the future. So you can't say exactly what's going to happen, but we can give some broad possibilities. And one way we could frame it, and this is how we framed it with the UK climate change risk assessment, was to look at scenarios of 2 degrees global warming this century, which is the Paris Agreement, the international agreement to limit global warming, aims to limit warming to well below 2 degrees, aiming for limiting warming to 1.5 degrees Celsius above pre-industrial. But anywhere between 2 and 1.5 degrees warming would be an achievement, regarded as a successful achievement of the Paris Agreement. So 1.5 to 2 degrees could be the minimum we can expect if we enact international ambition to limit warming. But it could easily be double that, actually. Our current trajectories would probably take us anywhere between 2 degrees and 4 degrees global warming, depending on, as I say, the strength of feedbacks in the climate system, whether we initiate various tipping points like loss of the Amazon rainforest, more permafrost, carbon release, as I mentioned, that kind of thing. So it's hard to say for sure. The best guess is tended to be regarded as about 3 degrees warming by the end of this century, but 4 degrees is easily quite possible. And that should be borne in mind, I think, that these higher end risks are still quite substantial. So what do these levels of warming mean for the UK and around the world? So these are some of the risks we assessed in the UK risk assessment. So the table at the top there is showing the present day impact, and then the impact projected for 2 degrees global warming, and then for 4 degrees global warming. So flooding is already costing us huge amounts of damages. I mean, flooding does happen anyway. Extreme weather does happen naturally, but we're making it more severe and more likely. But currently we get about £2 billion worth of impacts from the annual damages from flooding. That would increase to up to 3 billion with 2 degrees warming, up to 4 billion with 4 degrees warming. But as well as more flooding, we can also expect reduced water availability. And this is it's a bit of a paradox, it might seem, but actually you can get a situation where you get more extreme rainfall, but longer periods between rainfall. So you can get drier summers overall, even with heavier downpours. So you can still get lower river flows and increased drought. So water availability is projected to reduce by up to 20% in the UK at 2 degrees warming. It's hard to give a precise number because it's difficult to predict rainfall, but 20% reduction or 50% reduction across the UK at 4 degrees warming. A very obvious impact of warming is heat stress and heat-related deaths. We see about 2,000 of those per year in the UK. They'd be projected to increase to around about 7,000 under 2 degrees warming, or 13,000 per year at 4 degrees, if we don't take action to change our lifestyles, adapt buildings, and adapt to a hotter world. Wildfire is an emergent risk in the UK. We do have some fires, but nowhere near on the scale that is seen in other countries. But under a hotter climate and with drier summers, we'd expect to see an increase in fire risk, going from like a 9% of days with very high fire risk at the present day, up to 26% at 2 degrees warming and 50% at 4 degrees warming. So quite a substantial change to the landscape and the risk of wildfire in the UK. And then it's a similar story, but actually worse for the rest of the world. The UK although we're impacted, probably gets off relatively lightly in terms of our own internal impacts, because we're in a milder part of the world and we're kept relatively cool by the oceans around us, for example. So heat stress is a vast problem for the hotter parts of the world. The numbers of people exposed to extreme heat stress risk, they're in the millions already, but it would be coming into the billions for 2 degrees warming and 4 degrees warming. So places like the Indian subcontinent, which are humid as well as hot, the heat stress risk is very, very severe there. Flooding risks, again, would go up, as I showed for the UK. Drought risks, again, more time under drought. Wildfire risk, again, more of the world's land area, showing more time under high fire risk. And risk to biodiversity of many species losing large parts of their ranges under high levels of warming. I haven't got sea level rise on here, but we'd expect we could be locked into up to half a metre of sea level rise with 2 degrees warming already. So we are going to have to adapt to higher sea levels, but we could see more than a metre, possibly 1.5 metres by the end of the century on the global average, which would affect many low-lying coastal areas, both in the UK and around the world. So how are we doing addressing this? What we need to do to meet these Paris Agreement targets, especially if we are aiming for limiting warming to 1.5 degrees, warming above pre-industrial, we need to cut global emissions rapidly. This is a graph of what global emissions need to look like. They need to drop rapidly and become net zero. So that's the actual emissions minus any that we're taking up from the atmosphere by planting more forests or by carbon capture or whatever. So stopping putting more carbon dioxide into the atmosphere needs to happen around the middle of this century. And actually we need to be reducing, taking CO2 out of the atmosphere, actively sucking it out of the atmosphere in the second part of this century to be limiting warming to 1.5 degrees. So carbon sinks and carbon removal are going to be important. So but the main thing is emissions themselves need to reduce rapidly. The reality, of course, that's not happening. Globally, the top right, that shows various different regions of the world. Many regions have been rapidly increasing emissions. China in particular has undergone a huge space of development in the last 20 years, of course, other countries as well. The EU, including the UK and the US, have been gradually reducing our emissions, but nowhere near enough. That the UK, was announced this week by a Climate Change Committee report that although the UK has reduced its internal emissions, they're not on track to meet the UK's own targets of net zero by 2050 by any means. And that doesn't account for our role in global emissions as well, through aviation and through stuff we buy overseas, our kind of exported emissions, if you like. So we're nowhere near on track to meet this target yet. So just to summarise, the world is warming and it is our fault, and we are affecting extreme weather already. Some types are becoming more likely and more extreme. We're aiming to limit warming to well below 2 degrees Celsius above pre-industrial, or even limit it to 1.5 degrees. But if those goals are met, some further climate change is still going to happen. So actually, we're going to have to adapt some changes, but we're not even on track to meet those goals. We could see anywhere up to 4 degrees warming this century, the impacts of which would be severe, both in the UK and across the world. So we do need to limit warming. If we want to limit warming to 1.5, then we need net zero emissions by the middle of this century, possibly sooner. But we're not on track to meet that. Global emissions are not yet falling, although UK emissions are falling not fast enough. So that's it in a nutshell. And I'll be happy to take questions later on.